Now that this LLM thing is a thing, it's like forcing engineers to do it, like
Yep.
not the typical data scientist.
Hmm.
And yeah, so even in that like toy project, Stefan, that I told you about that I was like
Yep.
playing with, it would have been so useful to just be able to tell the LLM to come up with 5,000 fake questions,
Yep.
get those questions, and then just measure some like simple score at the end to
Yep.
see how it would perform in production or something, you know? Hey everyone, good to see y'all. Welcome to the Highlight Podcast. My name is Jay and I'm the CEO of Highlight.
I'm Chris, software engineer at Highlight.
And today we're talking to Stefan, the CEO of DAGworks, a dev tool startup building a developer-friendly way to iterate on their Python-based data, machine learning, and AI pipelines and applications. I've heard a lot about DAGworks because the company was in Highlight's YC batch, so it's good to see you again, Stefan. But it's been a while since we've caught up, so excited to dive deeper. If you don't mind, Stefan, would love for you to introduce yourself, and then let's get into what DAGworks is.
Cool. Yeah. Thanks for having me, Jay and Chris. So at DAGworks, DAG, or DAG for it stands for Directed Acyclic Graph, computer science term. We'll connect that in a bit, but we're on a mission to enable everyone to build reliable AI agents and applications. The two core constructs of that are pipelines and actual kind of application that uses them. We're fully open source and provide a unique integrated development and observability experience for those building anything, broadly speaking, in the AI space. So specifically, to unpack that a little is, we're building two open source frameworks that with a single line of code provide full production instrumentation that seamlessly integrates with data and observability products. So think open telemetry through to lineage and a data catalog is what we're trying to provide. One of the frameworks is called Hamilton, and it targets data, machine learning, and RAG pipelines, or retrieval augmented generation for those who don't know. The other is called BIRR, targeting LLM applications and agents. If you know your American history, you might get the naming reference between the two. If not, you can Google it. But without any spoilers, we see them as complementary rather than competitive. People use them to accelerate development to production cycles for data, ML, web, and kind of AI domains while reducing vendor bloat. Our solutions are used by hundreds, if not thousands, of companies from Netflix to IBM and through to banks and fintechs like Capitec in South Africa and Core Money here in the US. Now, to tie the name of the company back, well, both our open source projects have this duality between the code you write and showing a flowchart of how things connect. So you write code and you can kind of see visually like how they kind of connect. And one instance of a flowchart in computer science is a directed acyclic graph. And so we're all about this duality between code and visual, and so hence the name DAGworks.
Very cool. Very cool. And I feel like, Stefan, I've been, in my spare time, I've been building some small, like AI applications where you have like a tree of many prompts and you decide to do certain things based on what the input prompt looks like. So I imagine that's kind of relevant, at least kind of relevant to what y'all are doing. How has it changed, like since like the big wave of LLMs? How has your company changed and the types of use cases that people have built, that sort of thing?
Yeah. Great question. So we originally started, so my background is kind of, if you heard the term MLOps, or machine learning operations, is kind of where I spent a good chunk of my career.
Okay.
Hamilton actually, I created Hamilton at Stitch Fix, my prior company kind of worked at. It was we did a lot of build versus buy, so we built like everything you kind of need for classic AI in terms of getting it to production, right? Hamilton was the only thing we open sourced, and so we decided to start the company around it. And so in the case of LLMs, there is this, there's other popular libraries and frameworks, but one of the things that we realized is that if you can model things as a flowchart, right, there's many applications to it. And so if you think about choosing a prompt or going from taking some data, going to an LLM, taking some, parsing that response, and then doing something with it, that's all like a directed acyclic graph. And so what we didn't know quite at the time, I guess, when ChatGPT came out, is like how well kind of Hamilton already fit that paradigm.
Yeah.
But the new thing though is more kind of around kind of agents. So for those who don't know computer science, the directed acyclic graph is a flowchart where there are no loops, right? But if you were to draw an agent potentially can loop back to an action or a task. If you think about AI agents in terms of modeling them in terms of a flowchart, right? And so we built a second framework called BIRR to kind of handle it. So we saw, so broadly speaking, the abstractions of a directed acyclic graph and a graph or a general flowchart are two things that are pretty universal in the data space. But seeing that a lot more developers now, are actually having to contend with, how do you build software that inherently has some non-determinism in it? So how do you make it reliable? And so really what we've seen, our initial target focus was people with data and machine learning backgrounds, but with the new wave of AI, it's like, developers such as yourself, who want to build an LLM and build some reliable product, right, are going to have to learn all these kind of MLOpsy constructs to actually make it reliable. And so seeing a shift to, like the people who are now adopting our tools the best are engineers, and they're looking for these kind of solutions, or like, how do I, because instrumentation and observability, right, is a big core component to figure out whether something's reliable. Seeing them kind of gravitate towards what we're building.
Understood. So I think I understand Hamilton. It sounds like what it does is like it converts your code into like a graph that you can then visualize and iterate on, and you can edit what I say about edit the description. But I'm also curious about BIRR, because I think I am very much, Chris and I in particular are interested in the observability stuff and open telemetry stuff, but I want to make sure that we completely get it before we jump too deep. So do you mind giving just going deeper on each of the projects and like what types of use cases they allow for?
So like I think one thing to kind of help juxtaposition what I say, just to describe how traditional software is made reliable, right? So traditional software, right? You build an MVP, and then what do you do to make it reliable, Jay? Like, or Chris, what are the usual steps to productionize traditional software?
You test it.
You're right. Or you write tests.
Yeah, you write tests, and then you instrument it.
Right. Yep. And that's like that pattern. It's not that much effort generally. It's pretty easy to size, right? And then the instrumentation part is only when you get to production do you really care about that, right?
Got it.
And so, but that pattern kind of plays out with building kind of AI, data and code based kind of products, which is basically AI. There is, when you build your MVP, right, it is some form of reliable, but it's not like you can write unit tests and you're done. Like you're kind of on this journey to figure out how do you build this thing in a way that's reliable. And so, and the reasons why is, data can change from out from under you. So in the case of an LLM, right, you might have one prompt that's great for your demo because you fixed it, but in real life, the data being passed in is weird, and like you don't get the response you want. So it's kind of stuff like that. And so with both with Hamilton and BIRR, like the key to figuring out what went wrong is you need to observe, you need to instrument. And at a high level, I think, if you can draw a picture of how things connect, right, that's good visually from a documentation and like people getting started perspective. But that's also kind of what we leverage in the framework, is that we can auto inject and provide, rather than you putting log statements to say this thing started, like, well, the framework can do that for you. So hence like auto building the spans for open telemetry. Right, we can kind of do that from the graph. You don't have to go and instrument it. You don't have to add any like with context, set trace or whatever kind of stuff. It's just we can kind of leverage the stuff. And so, Hamilton's more like broadly speaking around data transformations. So because that's very generally DAG-like. With BIRR, it's around like, hey, I'm trying to model an agent conversing with an agent, or having an agent talk to a series of other agents, and they're trying to kind of perform some actions, and where there's some, should I take action X or action Y? You need to make a decision, right? Modeling, being able to model that as a kind of this flow chart is really kind of where BIRR is. So BIRR is in some regards, you could say, a slightly higher level abstraction than Hamilton. You can model, some of the same things in BIRR as you can in Hamilton, but if you saw the syntax and API, you'd see that there is different use cases for them. But so that's broadly speaking what I saw at Stitch Fix in my career at MLOps is that like most people forget about the instrumentation piece until it's too late, and then they're coupling, tying together. It's like tech debt, and then you're coupled to your infrastructure. And so wouldn't it be nice if the framework just allowed you to focus on like your nuts and bolts of getting stuff out, and then with like one line change you can then have it like fully instrumented, so then it's standard across what everyone else does, and easy then to like swap out some infrastructure without having to like do some really extensive migration stuff. So
got it.
Does that help
Nice.
frame?
Yeah, definitely. So on the data collection side, you mentioned OpenTelemetry. Does that do a lot of the heavy lifting there in terms of the auto instrumentation and things like that, or have you written a lot of that?
Yeah, so we it's a bit of both. So there is, I think, another YC batchmate, Traceloop, wrote a bunch of kind of OpenTelemetry compatible or implementations for some of the common LLM and kind of vector database kind of implementations. And so we leverage that instrumentation, but then in terms of the actual application itself, right, the standard of this agent took this action, and then because you can think of an action can be composed of multiple API requests. And so what's interesting or different for us is that we can actually, rather than viewing each API request as a separate trace, we can actually group it together under a larger action. And so that part is we instrumented kind of ourselves, and then but we leverage for the actual API requests the OpenTelemetry instrumentations.
Nice.
So is DAGworks like or I guess maybe if we're focusing on BIRR, is BIRR mostly used in like a development type environment for experimentation, or is it I would imagine it's useful in both regards, right? Like I want to ship this to production.
So the prior point I guess I forgot to make is that with regular software you don't instrument until you get to production. But what's interesting is that say you're doing LLM calls, the response you get back can actually help you in development. And make a better product, right? And so we're seeing the shift where the observability, if you can build a really tight development experience, you can use it in development. And then there is no change when you go to production because you're already instrumented, right? And
Makes sense.
So to your question is the idea is like both. We want you to be able to iterate quickly locally in development, and then once you go to production, there isn't any change, and then the fixing cycle and etc. You already know how to use that data, right? To then make it leverage it better. And so that's for me that's an interesting, I guess, question for you guys, whether you guys are seeing it. But like it's interesting that this telemetry that you're getting can actually be used to build a better product. It's not around latency, memory, or CPU utilization. It's actually like this. I have a customer service agent, and I'm tracing their conversations. So now I have 10,000 questions and responses that then I could do something with to help build a better product. Right?
Yeah,
so
and you can you can actually do it pretty doably locally.
Mm-hmm.
I think it's interesting, like the Python data notebook concept. I feel like it's very common for some data scientists to like import some spreadsheet of like a crap ton of data locally, do some work on it, and then like iterate on it. Over the last like 5 or 10 years. But now that this LLM thing is a thing, it's like forcing engineers to do it, like not the typical data scientist.
Mm-hmm.
And yeah, so even in that like toy project, Stefan, that I told you about that I was like playing with, it would have been so useful to just be able to almost like just tell the LLM to come up with 5,000 fake questions. Get those questions, and then just measure some like simple score at the end to see how it would perform in production or something, So that's pretty cool, and I imagine I could do that with y'all, right? Because I could, and okay.
Well, that's what we're building towards. I mean, like, so
Understood.
It can imagine there's a little bit of what's the metric? Okay, how do you do that? Then there's you want to build your application, but then now you want to run it with synthetic data, like. What's the user experience that you'd want? Is it like one prompt you want to optimize, or do you actually want to run it in the context of your application, right? And so we're trying to work with folks and find people who are interested to help flesh that out.
Got it. Understood. And then when it comes to like the observability setup there, what are most of your customers, or what are y'all imagining that looks like. Like, do I point it to a cloud-based endpoint? Like, I can just point it to in some open telemetry collector, and then I visualize it there? Or is it pretty common for me to run some Grafana type thing locally? Like, what does that all look like in terms of querying the data or the scores?
Yeah. I mean, that's a good question. I mean, like the open telemetry spec is pretty open in terms of what you can kind of pass in it. And so, so some of these contexts could be megabytes, right? So it's kind of interesting to see, like, we're not explicitly pushing the limits of the open telemetry kind of spec here, but in terms of what I want to say is that most engineers don't necessarily see that you could use open telemetry for this. There's a lot of incumbents who are basically like, you integrate an SDK, but it's not open telemetry based, right?
Got it.
It is. So Langsmith, for example, and fellow batchmates Langfuse, neither of them are open telemetry kind of compatible. They're their own thing, right? And so
Understood.
So I think there's a little bit of people are looking for a solution, not necessarily caring too much about the implementation, but then I think once they get into production, they're realizing, oh crap, like there's an open, like, or the person who actually knows Datadog really well, or like the telemetry space that goes, wait, you're bringing in another observability vendor, doesn't,
isn't it all the same? Yeah. Understood.
But then the key difference, I think, a good question is, okay, you can log that stuff, right? But then you generally don't go to, I don't think Highlight has an export functionality. It's not like I can query and get that raw data back, right?
Yeah. Right. For the most part, yes.
Right. And so this is where I think that this is the interesting kind of evolution of things, is where they're going. And so some of these platforms and systems, this is what we're kind of trying to help build out. It's like, okay, if you locally, you can store those traces, you can then annotate them, and then you can do something with them, right? Analogously, you can do something that with the self-hosted version in your production, or the hosted version we're building out. And so there is definitely, I think, a lot of overlap with traditional telemetry, and so but the product mindset is kind of different, because it's very much, it goes there. It's a sync. You might have alerts and monitoring on it, but you don't try to pull that data back out. Right?
Makes sense. I think Chris put a point here about developer experience, so maybe we'll kind of go like focus on that end. But on the developer experience side, what does it look like right now? So it sounds like it's some sort of code instrumentation where I can like annotate a function or some set of functions. Correct me if I'm wrong though. Yeah, like what does that look like, and how do I compare it to the more traditional Python notebook kind of situation?
So developers generally don't use notebooks. Usually kind of IDE kind of type development. So if we take BIRR, for example, so Hamilton does have some Jupyter Magic plugins, so we do have some stuff there. But assuming your audience is more engineering focused, I'll focus on BIRR.
Sounds good.
So with BIRR, the idea is you write actions. So you build a graph of actions, and so if you think of nodes and edges, if that term makes sense, the circle is the action, and then the edges are transitions. So basically, you can to do what to do next after a particular action, you need to kind of set up some edges or transitions, saying, go to do this action if the state value is y. And so I guess zooming back out. So basically, you write some Python functions. These represent actions. You have to annotate them with an action kind of decorator. The key thing that they need to do is they need to read and write to a state object. So each action is decoupled from each other by reading and writing to a state object. So with BIRR, we can actually do some checkpointing and some intelligent kind of caching and kind of interesting product features there. But then everything's encapsulated in that function. And so when you come to build the graph, you got to say, what are my actions and how are they linked? You can, with one line, you could do OpenTelemetry.instrument, right? And you'll get the request kind of instrumentation, and then you just got to add a little tracker then that will, take that instrumentation along with the BIRR kind of checkpointing and stuff, and ship it to a locally run, if you're just doing pip install, a locally run backend web service that then has a UI that then you can go and look at. So you can be in your IDE developing, right? You can then have your little app running, and then in a separate UI you can kind of see like it running live. You can kind of see the traces coming through. We have, trying to, this is where we're developing more. If you find some interesting point where something fails or hallucinates, the idea is you should be able to pick up from that point, from where you left off. So we've observed everything, and then we can actually restart your application from that point. And so then the developer experience of, if you're 20 steps into like observing some sort of agent or something, right? You don't have to start from 0. You could start from step 20 and just be test driven and even like iterate kind of that way. So there's like we even have a command line tool to pull some state that we've observed and to help you create a test fixture for it. So then you can really try to help close that development loop.
Interesting. And so if I wanted to like put some fake data through like a specific point in the process, I guess I can do that with this test fixture thing.
I was going to say, you could be test driven about it. The integration test is kind of, if you think about it, depending on what your application does, like if it doesn't need human input or something, like you can very much easily, kick off, 10 runs of your agent with different inputs or things, and then you could trace and get those values, right? So very flexible, in some regard. But yeah.
Awesome.
It sounds, the benefits sound very compelling, not having gotten to work on many, AI driven apps. What have been some of the roadblocks for people using some of the DAGworks tool chain? Is it just lack of awareness, or are they considering other options for, debugging or?
So, if you think of, a lot of people are looking at AI just for partly career development, career safety, like how do I build these things, right? And so we're seeing, a lot of developers, for example, you could say very much a classic computer science kind of engineer thinker, right? And so I think in abstractions, but so one of the things we're seeing is that a lot of people like not realizing that, hey, maybe you need to think of things as more of a state machine, or like this kind of graph-like approach for an agent. Like, hey, if you can draw the flowchart of what it's supposed to do, wouldn't it be nice if your code kind of could match and mirror that? Because else what people are doing is, they're building while loops, they're functions within functions, but then now you have to have how do you instrument it? Then you wrote a different agent in style J than Chris, and then now you have like the general software engineering challenges of like how do you standardize and unify. And so I think part of that's a little bit of market education and people feeling the pain and go, okay, I think I need to learn that there's a better way. And so seeing broadly, people saying like, how do I model this and how do I do it in a way that then I can actually go to production versus there are popular frameworks where in 3 lines of code you can have a great demo, but that doesn't help you get to production.
Yeah. What's your engagement with the open source community been like? I see you've open sourced all your tooling here.
Yeah. So I think one of our learnings is like for Hamilton, like we didn't actually open source the UI soon enough. So both Hamilton and BIRR come with UIs. They eventually we'll be able to consolidate them and have a unifying kind of way. But I think with data in particular, a lot of people I think are pretty security conscious. Like they don't want to ship stuff quite too much, and being able to see things on their own data is pretty crucial. And so this is where I think having something that someone can run locally with the UI is very, very key and critical. Like they're not going to buy anything anyway unless they get to production. So, it's really hard to kind of, get them to pay for something to, unless there are like enterprisey kind of features needed. But like the average developer doesn't need them to get started. So definitely seen like if you can do things locally with the UI and make it really easy to set up, it's like that's been helpful. We have, I think Discord is a better place or it seems to have less friction to join than Slack. And so with Hamilton, we have a Slack channel, and then with BIRR, we have Discord. And so seeing, at least anecdotally, that BIRR is growing faster, partly probably also because BIRR is targeting more engineers. And so, I think there's a high correlation between gamers and software developers, in which case Discord is a thing people already have installed. But otherwise, BIRR is at over 100 people. Having people contribute examples and small bugs and other stuff is kind of fun. And so seeing, having lived through Hamilton, I think we're applying the better practices to kind of grow that faster with BIRR. So.
Nice. So you've seen significant contributions from the
Yeah,
community back into the project too.
yeah. I mean,
You
so not
mentioned bug fixes. And,
yeah. So bug fixes or finding bugs, or like actually the biggest ones have been around examples. So like people, this is where like getting started. Okay, so you want to build an agent or bot, like having examples is what people want to be shown, right? And so that's actually where we've seen the largest contributions in terms of getting into the core. Like we have people who are actually building libraries on top of BIRR, for example, so their own high-level abstractions and things. And so, and I don't know, I want to say that speaks to some of our ability to get an abstraction right, but they really haven't actually had to. I mean, given our background, we try to add in the hooks and things to make it really easy to kind of customize and kind of add things on top. And so, no one's really had to dig into the core. So I want to say it feels like we've got something right there. But it takes, I want to say, a year or two for some people to really get comfortable to get into the core of something. I don't know whether with you guys, like, you found that similar, that, or unless there was someone from day zero who really wanted to like get into the internals. But
Yeah, I think we found that there are a few superstars in the open source community that like every once in a while will want to put something out, but then for the most part, it's a lot of like bug fixes and more just like supporting the project, which it sounds like is kind of comparable to your setup, right?
Yeah.
And yeah, it takes time too. It's like you got to really like support them in getting things set up and that kind of thing. Yeah, it's like a two-way street. So makes a lot of sense.
Yeah.
One thing I was curious about, Stefan, about the development to production route is that you mentioned that when I spin up like a BIRR project, I get like a little web server locally that I imagine I can interact with. And but how does that interact? How is that related to the productionizing of it? Because like, should I as a developer rely on the BIRR web server in production? Or what if I want one of the nodes to be like a distributed system, like, or have like be horizontally scalable, because I know I'm going to get like a lot of requests there. How does all that work?
Yeah. So so the BIRR UI is decoupled from the BIRR framework itself. So the BIRR framework actually has like 0 Python dependencies. It's pure Python. So in terms of dependency, just to clarify, like the BIRR UI is like an extra set of things that like you can run locally. It is decoupled. So we have had people who deploy it on AWS successfully, and rather than using a local tracker, they have an S3 tracker. So and we've seen, and they report back that there aren't any performance or other implications. And so the idea is your core logic should not change. You don't have to change anything. It's only like when you build your application, it's kind of swap out the S3 tracker for the local tracker, and your application is none the wiser about the BIRR UI.
Okay.
Right? And so that's kind of how we're thinking, because we really see where when you build the application, that's really where you should couple a lot of these kind of production or like infrastructure-y kind of concerns. And so in terms of the distribution nature, like BIRR just runs in process right now. We do have plans and extensions to help, if you support more of a map reduce type pattern over, say common things. But suffice to say, it's very easy to distribute or do whatever. And so this is where the paid offerings and other things would be around, potentially different. Rather than S3, maybe you want better, like an actual database or backend, or maybe you want Highlight or something. This is where, things we're thinking of and building and integrating. So
Nice. So would you say most of the use cases right now are like local first, where it's like experimenting, and then it's like you want to build out more of the production offerings over time?
Yeah. I mean, I want to say most people who are doing anything agentic aren't enterprise, right? It's still pretty early. It's mostly startups, and so they want infrastructure. And so, I mean, you build during development. So, and so part of the idea is, if you can help someone develop and you don't have to do anything to change instrumentation to get to production, well, then there's obviously a build versus buy decision that someone needs to make. And so either you self-host that everything in open source, or you use our hosted version, or license some other stuff from us for your self-hosted one, because you didn't want to build an authentication, for example, or something like that.
Got it. Understood. And then one thing that you mentioned, Stefan, earlier was about how observability for AI applications is different in the sense that you kind of need to instrument everything and then ship to production, because you're just going to regret not instrumenting some step that's like actually the bottleneck or whatever, right?
Yeah.
Could you say that that's the case for anything? Like, I'm kind of curious, like, why is it just AI, and is this just more of a as web platforms have matured, we've kind of agreed on the standard, which is open telemetry and not like a specific vendor, perhaps, and we should just be instrumenting everything? Or are there downsides to that? Like, what is your stance there?
Yeah, I mean, so if you think about APMs that, like, say, integrated, right? Like most people's observability ends at the request layer, right? If you want to instrument what's inside your web service, you generally have to, like, do that yourself, right? And so I want to say, yes, broadly speaking, everything should be instrumented. It might not be that useful in traditional software because you might be pulling more data than you need, but with AI software in particular, it's like the data really matters, right? And so and then also understanding the versioning of, like, say, your prompt and the data, and those two together can give you different outcomes. And so you really like, this is where the fidelity of the data point I think is probably a little different than traditional software. With traditional software, if something failed, it's like, okay, I know that code path, I know it failed, I could probably figure it out.
Yeah.
But
yeah.
with AI, it could be like, it's this particular input, right?
Sure.
And it's different from this one. And so I think there is probably a slightly more useful aspect to instrumenting kind of everything there than traditional software.
Understood. Cool. Maybe we can kind of like transition to more of like the future of the project, kind of given that, like, I think now we have a good idea of this. We talked a little bit about observability. What are you thinking about in the next year, Stefan, in terms of where y'all will go with the project? And I know there's Hamilton and BIRR. It sounds like maybe there's some talks to put that together. So just kind of curious at a high level.
Yeah, so I mean, so we already see people using Hamilton and BIRR together, and so really it's on the observability side. How do we build the experience that kind of can? Both of them come with great observability kind of constructs and things that they can emit and track, and so it's really around the UI or the services and the things. And so in the case of your example, we can capture it. We can start to annotate the good responses, bad responses, right? You then want to start to curate that into kind of sets. If you think about reliability and kind of to your point on evaluation, well, then you got to curate metrics and you got to kind of build that out. If you think about you get it to production, and then now you need to maintain it. You need someone else who's not you potentially to come in and service it, etc. And so how do you set up then a CI pipeline or a set of kind of constructs that then make you confident that, like, if someone is going to change something between the logic and the AI, because actually what's interesting is that those two things can start to be coupled. So if you have an agent that is taking an API request or like doing an API request against some internal service of yours, right? And you change the behavior of that, you're going to have to know and understand and track it, right? And so I see this kind of the software development lifecycle really being the one to be, like, figured out, and how do you get it fast? So most people are in the stage of, okay, I have the demo, how do I get to production? But then after you get to production, it's like, well, then how do I maintain it and how do I run a team? Because agile sprints don't work here anymore. Like, it's not like you just shipped a feature and you forget about it, because the reliability aspect, always someone needs to maintain, someone needs to monitor it. So, like, in terms of product stuff, is like we want to build out that experience to actually enable that software development lifecycle. The other side is that things will start to stack on top of each other. So it's really key, I think, from a standards perspective, that Chris, you wrote an agent, Jay, you wrote an agent, and then we couple it together to build a better product, right? That the observability just kind of flows through, right? And so, or you can see the same introspection between both. And so trying to ensure that this hierarchical composable nature really kind of works. And so this is where we're already seeing this with Hamilton and BIRR, where people use Hamilton within a BIRR action, for example. And so really trying to make that experience of composability and understanding, like, okay, given this conversation and it hallucinated, where in the conversation did things get off the rails, right? And so really trying to, which could be multiple API requests, multiple agents, right? And so being able to stick that all together and figure out like what is the UI or the single pane of glass that you go through to kind of debug that or see that or to kind of trace it. So
Understood. And then Stefan, I guess lastly, I'm kind of curious. The thing I've noticed about this world is that I do think there are a few companies that have like tried to build proprietary things to make it so it's easy to observe your like these sort of trees of LLM calls and things like that. Things like maybe Langsmith. I'm not sure. LangChain plus Langsmith.
Yeah.
And I think there's a few of those other types of companies, but I think that's mostly for production. Whereas it seems like the way you think about it is it's more of like you need to be covering both use cases.
Yep.
Yeah. Like, what's your take on that world? And like, what's the hot take?
Yeah. I mean, I was talking to some friends in terms of, you know, their struggles, and it was like, their regular software background, they're like, you know, the tests are flaky. I don't know, like, have I built a good product or not? I mean, and I was like, no, yeah, you need to kind of do both. You need to, you know, this is where, I mean, with machine learning, it was like what's called, you know, feature engineering. You'd build something, build a model, and try to evaluate it, and you'd iterate that way, right? With here, people, the software developers, like, you're trying to figure it out, like my demo works, but you know, like now I need it to cover production cases. How do I do that? And so I think the only way that you can speed up that dev to production loop is like, obviously there's a little bit of educating people on expectation setting. So when you tell your management you've solved it, you haven't, you'll be like, this is we're gonna have the first version, and it's gonna be, at least we're trying to aim for these types of metrics, right? So I think there's a bit of education there. But if you think about development locally, like there's a lot that you can, to your point, synthetic data. Can you simulate things? Can you do stuff before you get to production, right? That then can help you build it. And then, oh look, you swap the synthetic data capture with real data capture, and then, you know, continue that way, right? And so, So I mean, this is when I say, like, I like to think that this is the reason why, I don't know, we're a little ahead of the curve, is because I've seen this problem before with, you know, machine learning and MLOps, whereas all the other kind of you know, open source tool makers don't have the background that I have, or me and my co-founder have, in terms of thinking about these productionization aspects. And so, so to me, it's coming. And once more people have lived that development life cycle, I think it'll be clearer. So
makes sense. Have you done any work yet to like start to educate the early engineers that are like posed with these problems on how to think more like a data scientist almost?
So content with open source, I'm sure you know, is key. And so we have a blog, blog.dagworks.io. So if you want to subscribe, go ahead. This is where we're trying to put out this kind of content a bit. So I think a lot of people are first interested in show me, like, just I want to get something up and running. But then the longer form content of like, this is how you fit, so how it thinks. Like, so I have a, you know, upcoming blog post in the works on like PyTest, right? So PyTest, super amazing, super powerful, but then how do you build it for things where you don't want necessarily a pass fail? Like, it's okay for some things to be a little flaky, and so like, how do you,
or like above
build
some score or something? Makes sense.
Right. And so definitely, I think open source content here is key in that, and it's like is a core part of the strategy. And so I think with open source, you got to build a movement. And so, you know, I think reliable AI is that movement for us. You know, cool. So how do we enable everyone or every engineer to understand the best practices required to kind of build a reliable AI product? Understood.
Very cool. Cool. Well, with that, Stefan, the last question I'll ask, I keep saying this, maybe this is the third last question I've asked, is where can people find you? So give us some links, or Twitter links, or whatever it is.
Yeah, I mean, so I have a weekly newsletter on LinkedIn called Stefan's Newsletter. So if you're Stefan's Newsletter LinkedIn, it should be the top Google search result. We have a blog.dagworks.io, so that's from blogs from the team, and even, you know, some open source contributors. We have a Twitter, so Hamilton OS is the Hamilton Twitter handle or X handle. BIRR_framework is the BIRR one. DAGworks obviously is the handle on X, and then you can follow me on Twitter or X at StefKrawczyk. So Steph Krawczyk is my Twitter handle.
Nice, awesome, cool. Well, thanks for coming by. This was fun. I feel like I knew what DAGworks was before this, but I didn't know how relevant it was till Highlight until we reached out a few weeks ago. So I'm glad we closed the loop, and thanks for joining. It was really fun.
Yeah, appreciate it. Yeah, thanks for I want to say for teaching me about OpenTelemetry. So yeah.
Of course.